talk about bearing. Suppose we say the bearing of point A from point B. What does that mean? Okay, so let's say point A is here and point B is there. Bearing means if I go to point B and draw a straight line that points to the north. Okay, and then if I draw a straight line that joins B to A, then the angle between the two lines is the bearing of points A from points B. So that's what it means. In other words, the bearing gives us the direction of A from B. But to tell the direction using an angle, we must refer the angle to some other direction. So in this case, the direction north is normally used. And for example, if let's say this angle is 50 degrees, okay, then the usual way to write down the number is not just write 50 degrees, but to add a 0 in front of it, so to make it into 3 digits. So we say that the bearing is 050 degrees or 050 degrees, and rather than just 50 degrees. So that's a conventional way, a usual way to write it. Another way to describe the bearing is to write this this bearing in the form in this form: N (50 degrees) E. And what this means is that we start by thinking about the direction to the north, and then we imagine rotating the angle of the direction towards the east. So you have a line there pointing to the north. You rotate towards the east by 50 degrees. And that gives us the new direction, the direction of the bearing of A from B. So this is also another way to write it. So look at some more examples afterwards. Let's start from one example. Suppose I have a point P, Let's say I have a point X that is to the west of P, so somewhere there. To the west, so north would be up there. That's north. Okay, so that's south and west would be there, east would be there. Now let's say I have another point Y, which is to the south of P. Now let's say this distance is 20 kilometers and this distance is 30 kilometers. We want to find then the bearing of X from Y. Alright, so X from Y, let's draw a line joining the two. Now we've seen A from B just now, and it's the angle from the north direction. And here we have that north direction, so X from Y, angle from the north direction would look like it should be this angle. Okay, but when we talk about bearing, if we say that bearing is 050 degrees, we always mean in the clockwise direction. Alright, otherwise if we don't remember that, then if I just say 50 degrees, it could mean to the right or to the left. So when we just give a number like 050 degrees, it is always the angle in the clockwise, measured in the clockwise direction. So in this case, that angle, as I draw it, goes in the anti-clockwise direction instead. Alright, it goes this way. So that angle itself would not be the bearing of X from Y. To find the bearing, we got to go back to the north direction, and we got to go clockwise all the way until we come to the line joining Y to X. So it is this this big angle here that is the bearing. So in order to find this angle, we can start by finding this angle, because if we know this acute angle, then this is just 360 degrees minus that angle. So let this angle be theta. Okay, then this must be, the bearing angle must be 360 degrees minus theta. Alright. So now let's try and find theta. If you look at this triangle, you see that this must be a right angle, because this line is to the south, that line is to the west. So the angle is 90 degrees, and so we have a right angle triangle. Then we know these two sides. This side is adjacent to the angle, that side is opposite. So that's our opposite, that's our adjacent. Therefore, they are related by tangent theta. So tangent theta is the opposite over adjacent. And using the calculator, we can find the answer to this. And then from here, we can substitute it into here and calculate an answer for the bearing. Okay. Right, I'll look at another example on bearing. Let's start from suppose that there is a point A. Now there is a bird at this point, and this bird wants to fly to another point B, which is to the north of A. And the B is a long way away. B is 140 kilometers to the north of A. Now when the bird started flying, it did not go straight north. It went in a slightly different direction. Okay. And this direction is 20 degrees E of N. Now what does that mean, 20 degrees E of N? Now this means the same thing as N 20 degrees E. Okay, it means that with respect to the northerly direction, we turn the direction towards the east by 20 degrees. So this means that this angle is 20 degrees. So the bird flies, and it continues flying for 100 kilometers, right, before it realizes its mistake. So when it finally reached a certain point C, alright, it knew that it has gone too far, of course, and then it has to now change course in order to get to B. So the question now is, by the time the bird reaches C, how far is it from this straight line from A to B? What is this distance x? Right? So this distance would be the perpendicular distance. How far is it? And if it now has to change course, what bearing must it take in order to reach B? So that would be the north direction. So we need to find the angle between this new direction and the north. Right. So let's start by finding this distance x. We can look at this triangle. Now in this triangle, we have a right angle. We have this 20 degrees. Now that's the hypotenuse. So x then is the opposite to the angle. Okay, therefore we can use the sine, and sine 20 degrees is opposite over hypotenuse. So this allows us to calculate x. That's 100 times sine 20, and we can use our calculator to find an answer. Okay, that would be in kilometers. Same as that. Next, if I want to find the bearing, as the bird flies from C to B now in a straight line, I can start by finding this angle, theta. Okay, then after that I can calculate, I can either write down the bearing in terms of that angle, or I can find it in terms of this clockwise angle, all the way from the north clockwise to here. So either way, I can start by finding this angle. And let's see what we have here. Now we have this right angled triangle. Now x we should have found from here. Okay, so let's say that we already know what x is. Then in order to find this angle, we see that this angle is the same as that angle. Okay. So if we now look at this triangle, it is a right angle triangle, and we know this opposite side to the angle, and we need to find the angle. But the information here is not enough. Okay, we need to know another side of the triangle. So how should we do that? Now we can do it if we know another side of the triangle. Now let's try and find this side. Let me call this y. Now I know that the distance from A to B is 140 degrees. 140 kilometers. I want to find this distance y, and if I can find this other distance first, right, then I would be able to find y. Now this distance I can find using this right angled triangle, because I know that this hypotenuse is 100 kilometer and this angle is 20 degrees. So they can be, and this side is the adjacent to this angle. So let's say I call this side Z. Okay, then cosine 20 degrees would be the adjacent Z over 100. Okay, so from here we know that Z is 100 times cosine 20 degrees. So this means that we know that this distance is 100 times cosine 20 degrees, and therefore we can find y. Y would be 140 kilometers minus this. So let me write this down. Y would be 140 minus 100 cosine 20 degrees. Okay, so that's y. And we already know what x is. X is this. Okay, so we know x, we know y. Then we can find theta, because for this right-angled triangle, x is the opposite to theta and y is the adjacent. So they are related by tangent. Okay, so I have tangent theta must be equal to x over y. And we know that x is this. (100 sine 20 degrees). And we know that y is that. 140 minus 100 cosine 20 degrees. And we can use a calculator to then find theta. Okay, and once we know theta, we can find this angle. And once we have this angle, we can find the bearing by finding this big angle here. Okay, because this big angle is just 360 degrees minus theta. So that would be our final answer. The bearing is 360 degrees minus theta. After we have found theta from this expression using a calculator. Okay, we'll stop here.